first thing we're going to do is just factor out your greatest common factor, which it explains that here. Factoring is rewriting an expression in a product of factors. So like you did this, you know, in probably elementary school with numbers. If you were to do like a 12 and you would say 2 and 6, 2 and 3, well, that's 2 squared times 3, right? I mean, that's how you could write 12. 4 times 3, 2 squared times 3. So you're looking to put it in the factors that cannot be factored anymore, okay? And so with these, you're just looking across the board. Can I take something out that is in common to all of them? So if I were to look at this first one, the first thing I'm going to look at are my numbers. I'm going to look at the 4, the 20, and the 12 and say, do they have anything in common? Well, yes, they do. What's in common to all of those numbers?
4.
A 4. And so you put that on the outside, and you divide everything on the inside by that 4. So I have 4x squared divided by 4. That's just x squared. The 20 divided by 4, that's 5x. And the 12 divided by 4, that's just your 3. And so that's factoring. If I look at this guy, b, I am going to look at the numbers here. So I am going to look at the 9 and the 24. What can come out of 9 and 24? 3. But I'm also, in this case, going to look at my variables because I have variables in all of my elements here. So I have an n squared and an n. You're going to pull out the lowest one here. So my lowest one is n to the first power. So I'm going to take an n out. So I have 9 divided by 3, that is 3. I started with 2 n's. I took 1 out. I have 1 n left. 24 divided by 3 is 8. I started with 1 n. I took out that 1 n. I don't have any n's left. So that is the factoring of that guy. All right, so for these, we are trying to then go from a trinomial back to 2 binomials, okay? And so when you have something like this, you're basically going to say, well, what happens when I FOIL? So if I were to have something like this, x plus 2, I'm just going to write one to the side, x plus 2, x plus 3, okay? If I FOIL this, my first term is going to be x squared. And then I'm going to get these 2 middle terms. I'm going to get 3x and 2x. And my last term is going to be 6. When I simplify this, I add these 2 terms here. And I keep the first and last the same. So that's what happens when I FOIL. Now I'm going to go backwards. And so when I look at this guy that I just did, my first term is easy. It is the product of my first 2 terms in my binomials, okay? My last term is also somewhat easy. It is the product of my last 2, okay? The middle guy, that is going to be the sum of the products. So when I took my outer terms and my inner terms, I added those together to get my middle term, and that's how I got him. And so that's what you're looking for. You're looking for something that will multiply to give you this third guy, but will add to give you the middle one, all right? Now you have to pay attention to your positives and negatives and what happens. So if I have a positive guy, then I know that I had to multiply 2 positives or 2 negatives to get him, okay? If this were negative, then I know without a doubt I had to multiply 1 positive and 1 negative to get him. The middle term is based off of what you have decided about the last term. For the last term, I've decided this is a positive 6, so I must have multiplied 2 of the same sign, which means my middle term is going to add up to that number. It will add up to either a positive number or to a negative number, but it will be both positive or both negative to get a positive 6. All right? And so I would look at 6 and I would say, well, I could have a 1 and a 6, a 2 and a 3. Those are my only options for 6. I know that since it's positive, I'm adding them. Well, 1 and 6 would have given me 7 in the middle. 2 and 3, that gives me my 5 in the middle. And so I'm always starting with this end one, deciding if I'm having the same sign or different sign. So will I be adding or subtracting that to get the middle one? And then what 2 terms I actually need to use to get it. And so that's what we're going to do here. They gave us a prime, so it's really easy. All right. We have a positive 7 back here. That tells me I'm either going to have 2 positives or 2 negatives to multiply to get him. In the center, I have an 8. 7 is a prime. There's only one set of numbers that multiplies to give you 7. That's 1 and 7. Specifically a positive 1 and a positive 7. Those will multiply to give me positive 7, and those will add then to give me a positive 8. That's exactly what I need. I need them to multiply to give me a positive 7, to add to give me a positive 8. And so that's how I'm going to unfoil or factor this. I'm going to say x plus 1, x plus 7. And that is my answer. And I'm going to say this probably many times. Do not go back and remultiply him unless you're just checking your work. Because I've literally had people factor, then foil, and then box, and they just gave me the question as their answer, right? So this is your answer. You are factoring. This is your answer. Yes, we are going to use it to solve. That's why we're doing it. So factor, box your answer, be done. You can check it if you want to. You'll notice the only difference on this one is your middle term is negative. So I still have to multiply two numbers to get a positive number at the end, but now when I add two numbers, I'm getting a negative. So that means that both of them are negative in this case. I'm still going to look at my factors of 72 that add up to 17, all right? So factors of 72 that add up to 17, negative 8 and negative 9. If you multiply those two numbers, negative 8 times negative 9 will give you a positive 72. If you add those two numbers, negative 8 plus negative 9, it will give you a negative 17. And so I know that my factoring is going to be x minus 8, x minus 9. Again, you can check it by foiling it. Just make sure that that is your checking and not your answer. Example 4, the difference you'll notice here is that my last term is negative, which means I'm going to have a positive and a negative, which means I'm technically, while you're going to be adding the middle terms, one will be positive and one will be negative. So the rules of addition is one is positive and one is negative, you subtract and keep the sign of the larger, right? And so you're looking for two terms that do multiply to give you negative 12, but then they will add to give you a negative 1, which means you will actually subtract them, right, to get that 1. And so you're looking for the difference between the two terms to be that middle term instead of the sum. And so if the last term is a positive, you're going to have two of the same, either two positive, two negative, and you will always add to get that middle term. If the last term is a negative, you're going to end up subtracting to get that middle term. Okay, and so when I look at 12 and factors of 12 that subtract then to give me 1, that's going to be 3 and 4. All right, so I need a 3 and I need a 4. I need it to be a negative 1 when I put those two together. So which one's going to be negative?
4.
The 4. So I have a negative 4 and a positive 3. If I multiply positive 3 and negative 4, that gives me negative 12. If I add positive 3 and negative 4, that gives me negative 1. So I know that my factoring should look like this. When you have 4 terms, you factor by grouping. All right. The first one, number 1 up here, I am literally going to take the first 2 and the second 2 and group them with parentheses. So I'm going to say, well, I'm going to group these guys and I'm going to group these guys. And then I'm going to take out my greatest common factor between those groups individually. So if I look at this first group between 8v cubed and negative 12v squared, what is my least or my greatest common factor? Well, first between 8 and 12, yeah, and then the v. So I have 4 goes into both of those, and v squared goes into both of those, right? And 8 divided by 4 is 2. I took out 2 of my v's, so I have 1. 12 divided by 4 is 3. I took out both of my v's there, right? Let's look at the next one. Between 14 and 21, what can I take out? 7. So 14 divided by 7 is 2. I still have that v. 21 divided by 7 is 3. Okay? Now, if you factor by grouping and it can be factored, it should look like this, meaning that guy that's still left in parentheses should be the same. So what we're going to do is we're actually going to factor these. We're going to look at this compared to this. What do they have in common? Well, they have the entire group in common. The 2v minus 3 is in common, right? So then what's left over? Well, what's left over is the 4v squared plus the 7. And that is my factoring for that 4-term thing, all right? So the next one, I'm going to do exactly the same thing. I am going to group the first two, and I am going to group the last two. The problem is, in the last group, I grouped behind a negative. So I technically pulled a negative out, okay? Which means the negative 8x is now 8x, but that positive 1 should now be a negative 1. Okay, so anytime you group behind a negative, your very last term will change signs. So I need to change this guy to a negative 1.
But the 8x
What would happen if I were to put this back through, let's say take away my parentheses. If I took away my parentheses here, nothing changes, that's a 1. 1 times that, it'll stay the same. If I take out my parentheses here, negative times 8x is negative 8x, which is what I started with. Negative times negative 1 is positive 1, which is what I started with. So you only have to change the very last term when you group behind a negative. And now I'm going to do this exactly the same. So I am going to say what's in common between 64 and 8. Well, that is 8. And between the x's, that's x squared. And I end up with 8x minus 1, right? Anything divided by itself. Now, can I take anything out of the second group here? No. So if you cannot take anything out, you write a 1. Hear me out. If you don't, you will forget him. So write a 1, because you can always take a 1 out of something, and put your 8x minus 1 here. Okay? Always put your 1 or you'll forget him. So then what do I have in common? Well, I have the group 8x minus 1. And what do I have left over for my second group? Well, that's 8x squared minus 1. If you do not put the 1 there, you're going to have just an 8x squared there, because it will happen. All right? And so if you put the 1, it's going to remind yourself that it's a whole group, a binomial that should be there. So go ahead and try 2 and 4. For this one, you'll notice we have a leading coefficient. And so all of a sudden, we can't just think about the last guy and the factors of that add up to the middle. First of all, if you look at this, there are no factors of 5 that add up to 16. Not going to help you, okay? So now you have to consider your factors of your first term and your factors of your last term and how they could pair together to get the middle term, okay? You can still pay attention to the sign. That is still a positive 5, which means it's either going to be a negative or a negative and a positive and a positive. In this case, my middle term's a negative, so it's going to be a negative and a negative. So I automatically know that I'm going to have factors of 5, negative and negative, that multiply. But then how am I going to group those with the factors of 3? And so you have to look at your factors of 3 and your factors of 5, and you can say, how am I going to pair these up to get there? Well, 1 and 1 gives me 1, 3 and 5 give me 15, 1 plus 15 is 16. All right, that's one way you could pair them, which is what we want. But let's say I did 1 and 5 and 1 and 3. That would give me 8. So there's two different inside numbers you could get with these two groups. In this case, I want to multiply the 1 by the 1 and the 3 by the 5 so that 1 times 1 is 1, 3 times 5 is 15. Those added together give me what I want. If you want those multiplied together, they have to be in opposite groups, okay? So if I have 1x as my beginning and 3x, all right, that's going to give me my 3x squared. I need the 1 to be multiplied by the 1, so that is going to have to go over here. Has to be in the opposite group if I want it multiplied. If I want the 3 then multiplied by the 5, it also has to go in the opposite group. All right? And then I know I'm going to have two negatives because I need a positive 5 and a negative 16 there. All right? That is one way to do this. Now, I will say when it's two primes, 3 and 5, it's pretty straightforward. You have two options, right? Had that been 8 and 24, you'd be sitting here all day doing this annoying, right, factoring, okay? Or even if it were like 4 and 12, okay? Then you have 1 and 4, 2 and 2, 1 and 12, 2 and 6, 3 and 4. And then you have all these crisscross, which way is going to give me my little term that I'm looking for. You can use the 4-term factoring to do this, okay? So we're going to look at how we do that. All right, so we have this 3x squared minus 16x plus 5, okay? The first thing you do is you multiply across. So I'm going to take my 3, this is sometimes called the rainbow method, by the way, and I'm going to multiply it across to my 5, all right? 3 times 5.
Channel 2.
So I have 3 times 5, that gives me 15, all right? Now, I want to look at factors of 15 that will give me 16. Well, that's pretty easy. 1 and 15. I needed positive 15, right? Because that was 3 times positive 5. But I needed to add up to be a negative 16. So that's going to be negative 1 and negative 15, right? Does everybody agree? That will. So now what I'm going to do is I'm going to take my original and I'm going to rewrite just the middle term with these factors. So what does that mean? Well, I'm going to take my 3x squared. I'm going to leave that alone. And now instead of negative 16x, I'm going to write negative 1x and negative 15x. All right? Do you agree that that's negative 16x? Okay. And then I'm going to leave my last term alone. Now I have a 4-term polynomial. How do I factor 4-term polynomials? By grouping. And that's what you're going to do. So I'm going to group the first, group the last, and of course change him. What can I take out of 3x squared and x?
1.
Just an x, right? So I'm left with 3x minus 1. What can I take out of 15 and x and 5? 5. I'm left with 3x minus 1. I have 3x minus 1 and x minus 5, which, since order doesn't matter, is the same thing of the answer that I got before, okay? This method will always work. Like I said, when you have two primes, you may just want to be like, okay, pair, I know what to do. But when you have something that's not a prime and you're going to have to try to pair up 3 or 4 things and figure out which order it goes in and whether it's in the opposite group or the same group, you may want to do this factoring and just go across, make it a 4-term, and then factor by grouping is straightforward. It's the same every single time. All right, go ahead and solve those 3, and you may do either method. All right, so you do have some that are special cases here. Factoring perfect square trinomials. When you have a perfect square at the beginning and a perfect square at the end, you can check to see if you have a perfect square trinomial. And so what you do is you take the square root of the first one and the square root of the last one, and you multiply them together and double it. And if that gives you the middle term, you have a perfect square, and you can go straight to the factoring, which is a plus b. And we'll look at them so you can see it. The same thing is true if it were minus. Now, to have a perfect square, your last term must be positive, because there's no way you're going to multiply two of the same number and get a negative number. That's not possible. They either have to be two negatives or two positives, which will give you a positive. All right, and so let's look at what I mean by that. So if I look at this one, 9 is a perfect square. Technically, 9x squared is a perfect square. What is the square root of 9x squared? 3x. If I look at the last term, 49 is a perfect square. What is the square root of 49?
7.
So if I multiply those two, I get 21x. And then I need to double it because there will be two of them, right? When you FOIL, you have two inner terms. So double it. That gives me 42x. That is my middle term. I have a perfect square.
It doesn't matter if it's negative.
So the question is, let's look at this to determine what your sign is of your perfect square. I'm going to have my first term as the first term. I'm going to have my last term, that square root, as my last term. My middle, plus or minus, is going to be determined by my middle term. My middle term is negative, so that's going to be minus. And you can just say, well, that's squared. If I were to factor this, I would get 3x minus 7, 3x minus 7. That's what I would get. Now, it's much easier than doing all your factors of 9 and all your factors of 49 and pairing them up to get your 42, or even definitely multiplying 9 by 49. I wouldn't do that either. So recognizing you have a special case is vitally important to doing these quickly. Okay? So with special cases, as soon as you see a square root at the first and at the last, you're going to immediately check to see, do I have a special case? All right, do those terms, multiply and double to give me the middle term. Then I can go straight to my factoring without doing any other method. So go ahead and do these three. Next special case, if you have a perfect square minus a perfect square, always minus, it only works for minus, it will always factor to the square root plus the square root minus the square root. Let me show you one before you leave. This is a perfect square. This is a perfect square. The square root of x squared is x. The square root of 64 is 8. My factoring will always be x plus 8, x minus 8. Always. This is a perfect square. This is a perfect square. The square root of 4a squared is 2a. The square root of 49 is 7. My factoring will be 2a plus 7, 2a minus 7.
So you'll do